Hello, so today what I want to do is I want to introduce these little voltage divider boards that I make and explain a little bit about how to use them and why I actually make them. As many of you know, most of these devices like this Teensy and this Arduino Uno, they have a pull-up resistor that you can activate, which functionally becomes a voltage divider internally, but they're suboptimal, especially for educational purposes. They become black box-ish, for lack of better words. You can't really explain the physics behind it, whereas having an external one like this makes it really easy to for students to understand it, and it also gives you, in many cases, a better dynamic range. It just works better than the internal pull-up resistor, and I'll demonstrate that here in a moment. But I do want to show you a quick little web link here. So one of the nice things about using an external device like this is we know the value of this resistor. Okay, I'm going to give you a 10K resistor. So in physics and electronics, it means that we can do reasonable calculations. Now it's possible to find out the resistance of the internal pull-ups, but they tend to vary from product to product and even year to year from my experience, and then they don't tend to be that tight. Whereas this guy is going to give you a reliable, reproducible 10K resistance right here. And then of course this is going to be your external variable resistance device that you're going to be using to measure, for example, temperature or light or flex or whatever else. But let's go back to the actual setup here. You can see that I have both a Teensy and a Patton robotics motherboard and an Uno sitting here, and in both cases I have a voltage divider board connected. Okay, the Patton robotics motherboard, super easy. You can just use a 3 filament wire, because of course every single pin has its own source of voltage and ground. So that way I've actually hooked up to A0. The red wire is going to be getting 5 volts in this particular case, and of course the ground is ground, and it goes to the voltage divider board. In this case, the Uno, what I've done is I've had to use individual wires because there's only so many grounds available on an Uno if you're using it just in its native state. And I have the yellow wire hooked up to A0, and then I have the red wire hooked up to the 5 volt supply, and of course I have the black wire going to ground. In both cases I have a variable resistor, a photoresistor, plugged into these terminal blocks on the voltage divider board. So this is going to be our second resistor. This is going to be our first resistor. Going back to this diagram, the photoresistor is going to be here, and then our fixed resistor, this one, is going to be soldered onto the board, and it's 10K. So to play with these guys, probably the easiest thing to do is there's already a wonderful little basic piece of code that's built into every copy of Arduino. If I go to examples, I go to basics, and I go to analog read serial, I end up with a pretty nice piece of code that will work just fine for what we need to do. I will say that I don't like this delay being 1 millisecond. It works, but it's so fast that it's impractical to be able to read. So I'm going to make that 100 milliseconds. And you can see what's going to go on here. We're going to open up a serial port, and then we're going to, in a single line, we're going to take and read an analog value from pin A0, and then we're going to go ahead and put into a variable that we created called sensor value, and then we're going to print sensor value. And I have this one currently set up for the the Uno right here, and it's on COM12. So let's load this up and take a look at it. And perhaps I'll pause while it's loading. Okay, so it's done loading, and actually let's look at it with the serial plotter. It gives us a nice display, and we move this over here so we can kind of see it, and you can see that I get a really nice range of response, okay, with that photoresistor. It's exactly what you would sort of expect. Now, let me go ahead and compare that. I'm going to move over to this device. So let me pause it, set up the code, because what I have on this one is I have a photoresistor here and here. And what I'm going to do is compare the internal pull-up resistance versus a voltage divider. So I'll be back in just a second. Let me pause. Okay, so let's take a look at what I've done here. Of course, I've changed it. If you'll notice, now it's a Teensy 3.2, 3.1, so I am going to be talking to this processor. And I moved it to a new COM port, which I did under Tools, so I reset those. This is kind of important because I am going to be taking another reading, and I am actually interested in gathering data from a pin which has been charged. So keep in mind the way that works is here's my pin. When I turn on an internal pull-up, what I do is there's a resistor that connects to this pin, alright, and essentially it allows current to flow to the pin. So now there's a pile of electrons that are on this pin. If I take this pin and connect it to ground, okay, of course those electrons have a free path to ground. If I put it to a variable resistance device like a photoresistor, only some of those electrons can escape per unit time. So at any one moment, if I ask how high the pin is, so I query it, there's electrons flowing in, there's a photoresistor or some other variable resistance here, and then I ask the pin, well, how high are you? Okay, well, it's going to depend on how many electrons are escaping at that moment. If the resistance is high, okay, resistance is very high, then only a few electrons can escape, and I'm going to get a high value when I ask. All right, if the variable resistance is low and it's opened up, well, then those electrons can escape to ground, and I'm going to get a very low value. All right, so what I do is I do that by turning on the input pull-up resistor, okay, with this command right here. So I've set it up on pin A9. The Uno doesn't have that many analogs, but that's okay. So that doesn't direct you. I think you can only go to A5 on the Uno. Then I'm going to go ahead and take two different readings here. So I'm going to take a reading on A0 and A9. And notice that in this particular case I do not print on a new line. So I'm going to have the value of 1 and then a space in between and then the value of second. So when we look at it in the serial monitor, we get two columns of data that are separated by a space. So that's going to give us the ability to do plots. And if I move over here to the serial plotter, we get two nice graphs because there's a space between the data sets. And now you can see that I have this huge dynamic range on this 10K variable resistor, and I have actually a pretty minor range. Oops, let's keep them on the same scale. There we go. I don't have near the range. Oh, that must have been actually shorting out. Oh, yep, look at that. I'm sorry, I touched these two pins together. This particular peak here was bogus. Okay, it was an error. So here's my range on the internal pull-up, and here's my range on the voltage divider board. So I get a much bigger dynamic, and actually when you look at it carefully, it's a pretty smooth and nice fit curve. So let me do something with this, and let me pause it, and we'll play with it just a bit, and I'll show you how you can utilize this variable resistance. Okay, so I've decided what I'm going to do is I'm going to use one of these tricolor LEDs, okay, and I'm going to use the photoresistor to variably dim one of the colors of the LED light. Now to do that with an Uno, what I have to do, I can actually hook up a bunch of wires to it externally. It would be nice though to be able to just plug it straight into some convenient place. Now to dim a light, I have to be able to use PWM, pulse width modulation. That's the only way that I can dim a light. I can't use just any digital pin. I have to use one that has the capacity to be able to emulate an analog value out. And if we look at the Uno, we can see that the PWM pins, these right here, are kind of few and far between. But here's 3 in a row, which is nice, because what I want to be able to do is I want to be able to plug this guy in, which has red, green, and blue on 3 different pins, and then a common ground. So what would be really desirable is to somehow plug it into these three for red, green, and blue, and then set up either this one or this one and make it a common ground. Well, I can kind of cheat with that a little bit, as long as I don't get carried away with the current. Something small like this LED will work just fine. And what I'm going to do is I'm going to set it up so that pin 8 essentially functions as the ground for one of these pins when I light up the LED. So let me do that, and I'll show you how I did that. But for starters, I'm just going to go ahead and plug in this guy. So the ground in this particular case is this pin here, the one on this outer edge. So I'm going to plug it into the Uno like so, so that essentially pin 8 is what I want to make a ground. So let me pause it and set this up, and I'll explain what I did. Okay, so remember what I was trying to do is I want to set these 3 pins up that I can use the variable LED intensity. So I want to use PWM, and I want to turn this guy into a ground. And what I've done right here is I've taken pins 8, 9, 10, and 11, okay, which are these 3 or 4 pins that this LED is connected to, and I've turned them all into outputs because ultimately I want to make them light up. Okay, but remember 8 is the one that I've set up as a ground. So what I've done is I've said, okay, well, let's take and digital write to pin 8 and make it low. In other words, let's set it to ground, so that way the light wouldn't light up. Alright, so now I have set it to ground. Most all of these pins can sync more than they can source. You do have to be careful though. I mean, you get carried away and you plug in a bunch of stuff, I assure you that your chip is going to get hot and it might fry the thing out. But for a single LED, I think we're okay. Probably even 2 or 3, as long as I don't make them full force. Once again, I think we're okay. But be cautious. This is suboptimal. You'd be better off to have this hooked straight to ground. But I just want to demonstrate its feasibility. Now I'm going to go ahead and take this value in, and of course I'm going to display it. So let's go ahead and make it dim. What we should do actually, let me upload this and pause it so we can see the values. Look at that. I just want to make sure that you understand that I make mistakes too. I was switching this from the Teensy. There is no A9 on an Uno, so we need to get rid of that. Okay, and I'll be back in a second. Okay, so I've got this running, and you can see that we're getting values low as 65 and as high, by putting my finger over it, as about 300. So 65 to 300. No, a little higher. Cover completely. Let me cover this completely. Wow, we can go as high as 550 maybe. Okay, so from 65 to 550. Just remember that, and I'm going to pause. Okay, so let's take a look at what I did. I did all this here to set up the LED, and I've added one additional line which has got a lot of functions going on. So first off, I'm going to analog write. So in other words, I want to change in the analog value between 0 and 5 volts, for example. I'm going to use the green pin because it's red, green, blue, so it's the middle pin. So in this case, I know it's pin 10. And now what I want to do is I want to scale that input data. Remember, it went from 65 to 550. So what did? Well, the value we got from the variable resistor, all right, goes from 65 to 550. So I'm going to put the low end here, the 65, the high end here to 55. And what I want to do is I want to rescale it so it fits between the analog write output, which is between 0 and 255, an 8-bit number. So a 65 is going to turn into a 0, a 550 is going to turn into a 255, and it's going to automatically scale anything in between. And you can see that if I open up the plotter here, and there we go, and you can see on this LED right here that although it's not the best with the image, that in fact I get a nice variable light, and it corresponds to changes in resistance on the photoresistor. So hopefully that was informative, and I'm going to show you another cool sensor here in a minute, and I'll see you again soon.